In cold like this, a human body can begin losing control in minutes. Some survive by sharing heat. Others carry natural antifreeze inside their bodies. One can freeze solid until its heart stops beating completely. And another can almost shut down life itself. These are the true survivors. The animal at number 1 is not the polar bear. Survival is about more than fur. The coldest places on Earth are not empty. They are home to extraordinary life. They are home to animals that have spent millions of years evolving ways to survive conditions that would quickly overwhelm the human body. Some trap every bit of precious heat. Some slow their bodies until they barely consume energy. Others prevent ice from destroying their cells, or survive by placing life itself on pause. This isn't a ranking of the biggest or the strongest. It's a countdown of the most extraordinary cold survival strategies nature has ever created. Let's begin. Number 10. At first glance, the reindeer may seem like an ordinary Arctic herbivore. Number 10. The reindeer may look like an ordinary animal wrapped in thick winter fur. But nearly every part of its body has been shaped to conserve vital heat. Its hollow outer hairs are designed to trap insulating air close to the skin. Its broad hooves spread the weight of the animal across the deep, soft snow. Before freezing air reaches the lungs, a maze of tissue inside the nose recovers warmth. This process captures moisture and heat from every breath the reindeer takes. Even the blood moving through its legs follows a very carefully controlled path. Warm arteries pass close to cooler veins, transferring heat back toward the body. The reindeer survives the Arctic not by generating heat, but by wasting none. But the next animal uses a far more dangerous survival strategy. Number 9. Beneath the frozen ground, the Arctic ground squirrel disappears for most of the winter. Its heart rate falls, and its breathing becomes almost impossible to detect. Its body temperature can drop below the normal freezing point of water. Yet ice does not spread through its tissues. It enters a supercooled state. This reduces its metabolism until the energy demands of its body become extraordinarily low. Then, at intervals, the body begins warming itself again through intense shivering. Its heart accelerates, and its muscles generate the heat needed to survive. The reindeer conserve heat through thick coats and collective survival against the biting cold. It is one of the closest examples of placing life on standby. But hiding beneath the ground is not always an option. Number 8. The musk ox survives winter in the open using a coat beneath a coat. Long outer hair blocks the wind, while underneath lies a layer of kiviot. This extraordinarily fine insulation traps warm air directly against the animal's skin. When the storm becomes too powerful, survival becomes a group effort. Adults close ranks, turning their massive bodies to absorb the force of the wind. Calves move into the protected center, shielded by the walls of thick fur. The animals on the outside absorb the storm for the rest of the herd. They do not outrun the blizzard. They stand and endure against it. But soon, thick coats and shared warmth will no longer be enough. The next survivors are predators built to hunt in a world of snow. Number 7. The Arctic fox is built to prevent heat loss entirely. In this frozen world, losing heat for even a few hours can mean death. Number 7. The Arctic fox is one of the smallest predators in this frozen world, and that should place it at a real disadvantage in such a cold climate. A small body loses heat more quickly than a large one in the wind. But almost every exposed part of this fox has been reduced or protected. Its ears are short, reducing the surface area where heat can easily escape. Arctic foxes are masters of stealth. Its muzzle is compact, and the body is kept low to the snowy ground. And even the undersides of its paws are covered in thick, dense fur. Its winter coat traps a layer of warm air very close to the skin. Its enormous tail can be wrapped across the face like a natural blanket. Yet surviving the harsh Arctic requires more than simply staying warm for hours. Every unnecessary movement wastes vital energy that the fox must keep inside. The fox walks carefully, rests in a compact position, and listens for prey. It listens for the sound of prey moving deep beneath the cold snow. When it finally attacks, it receives only one brief opportunity to succeed. A missed jump means lost energy and a cold, empty belly for tonight. So it does not panic, it simply stops and listens once again. The Arctic fox survives because it wastes very little heat and no effort. But the next predator carries insulation on an entirely different scale. Number 6. The polar bear is not simply a land animal living near the ice. It is a marine mammal built around the life of the frozen ocean. 2 layers of fur protect the body from the biting wind and cold. Beneath the skin, a heavy layer of fat reduces heat loss in water. They become powerful paddles when the bear begins to swim through the sea. The bear can climb back onto the ice and continue moving with ease. For a polar bear, producing heat is easy. Losing it can be harder. Running or struggling for too long may cause the animal to overheat quickly. Even in the Arctic, it often moves with a high level of patience. Slow steps, long periods of stillness, and carefully controlled bursts of effort. The polar bear is a great example of a body sealed against cold. On the coldest breeding ground on Earth, survival belongs to group. Few places on Earth are as unforgiving as the Antarctic winter. Here, the cold is relentless. The wind never seems to stop. And there is nowhere to hide. Yet every year, thousands remain here. Thousands of emperor penguins remain here to raise the next generation. A father balances a single egg on his feet. Protecting it beneath a fold of warm skin. If the egg touches the ice for even a short time, the relentless cold poses a threat, and without vigilance, its chances of survival may disappear. But the greatest defense is not the feather, it is the huddle. Or the layer of fat beneath it. It is the colony itself. Each bird shields the others from the wind. Those exposed to the freezing edge slowly work their way inward. Those protected at the center gradually move outward. No leader gives the signal. No individual controls the movement. Of collective survival in the animal kingdom. Weeks pass, storm after storm. Until finally, new life emerges. Not because one penguin was stronger than the cold. The chick finds safety within the crowd, surrounded by a warmth found only in their numbers. Even so, sharing warmth has limits. Every animal we've seen until now still depends on maintaining body heat. The next survivor abandons that idea completely. Instead of resisting winter, it turns the frozen wilderness into its hunting ground. Number 4. Rank 4. In the cold mountains of Central Asia, low temperatures are just part of the challenge. The air is thin, the winds are fierce, the snow is deep. And every single step can consume precious reserves of energy. The snow leopard exists in this world by almost disappearing from it. Its thick fur limits heat loss while blending the body into rock and snow. Small ears reduce the surface area exposed to the freezing mountain air. Wide nasal passages help warm the air before it reaches deep into the lungs. Large paws disperse weight on soft snow, acting like natural snowshoes. Fur under the paws provides insulation and extra grip on ice and rocks. But adaptation to cold is not just about physical structure. It is also in how the animal manages its energy. A snow leopard cannot afford to waste strength on every target it sees. It approaches slowly, using the terrain to conceal its every movement, and only acts when the opportunity is good enough to succeed. If detected too early, it often stops instead of pursuing a long chase. At this altitude, a failed effort could cost many days' worth of energy. Powerful hind legs help it overcome steep rocks and short mountain gaps. When resting, the thick fur on the tail can be wrapped around the face. It does not survive by the highest speed or the greatest strength. It exists through silence, the ability to save energy. But no matter how well adapted, it must keep its blood from freezing. Number 3. Beneath the sea ice surrounding Antarctica, the water can remain below the normal freezing point of fresh water. For most fish, that creates a lethal danger. Their gills are constantly exposed to the ocean. Here, antifreeze glycoproteins interact with ice crystals, preventing freeze tolerance. And microscopic ice crystals can enter the body with the surrounding water. Once a crystal begins growing inside an animal, it threatens to turn cellular water to ice. It can pull more water into its structure. Damaging cells and eventually freezing the body from within. But Antarctic nototheniod fish possess an extraordinary defense. Antifreeze glycoproteins circulate through their blood and other body fluids. When these molecules encounter a tiny ice crystal, they move naturally toward the crystal's facets. They attach themselves to its surface. They do not heat the blood. They do not melt the ice. Instead, they restrict the crystal's ability to keep growing. This allows the fish's body fluids to remain liquid at temperatures where they would otherwise be vulnerable to freezing. Over evolutionary time, this adaptation helped an entire group of fish. Athenoid fish occupy one of the coldest marine environments on Earth. Here, antifreeze proteins protect them from the sub-zero temperatures. Their survival depends on a delicate balance. The surrounding ocean remains liquid because of its salt. Antifreeze glycoproteins prevent crystal at the cellular level, and the fish remains alive because microscopic ice is prevented from spreading, unchecked through its body. But antifreeze has a limitation. The animal must still avoid becoming fully frozen. The next survivor uses the opposite strategy. By every sign normally used to recognize a living animal, this northern woodland frog is no longer alive. This frog appears to be dead. Its body is rigid, its lungs are silent, and its heart has stopped beating. But beneath the frozen leaves of northern forests, this is not death. It is a controlled biological shutdown. As winter arrives, ice begins forming around the frog and within spaces outside its cells. The northern woodland frog slows, its body preparing for the harsh winter ahead. Water is drawn away from. At the same time, the liver releases enormous amounts of concentrated glucose. This concentrated sugar spreads through the body, helping protect tissues as water disappears, and ice expands around them. Gradually, the frog's breathing stops and movement ceases. Circulation nearly vanishes, and much of the animal's body water becomes frozen. For weeks, sometimes longer, the frog remains beneath snow and leaves, with no visible sign of life. It cannot escape. It cannot feed. It cannot defend itself. It simply waits. Then, finally, the spring returns. Ice begins melting. Liquid water moves back through the frog's vital tissues. The heart contracts again. Breathing resumes. Muscles within the body begin responding. And the animal that appeared frozen beyond recovery slowly crawls back into the forest. The Antarctic fish survived by preventing ice from growing inside its body. This frog survives by controlling where freezing occurs and protecting its cells. It is one of the most extreme examples of freeze tolerance in vertebrates. But it is still only number 2, because the final survivor is different. It does not depend on maintaining circulation, a heartbeat, or normal cellular activity. When conditions become impossible, it can reduce life to an almost undetectable state. Follow the spring frog as it moves out of frame toward the leaves. Narrator. Beneath the frozen leaf litter, a northern woodland frog endures the harsh winter. This animal does not fight the cold. it nearly stops living. The tiny survivor retracts its limbs and enters a compact, dormant form. Number 1. This creature is so small it is nearly invisible to the naked eye. It enters a state called cryptobiosis. It lacks thick fur, a layer of insulating fat, or any antifreeze blood. And it cannot generate heat to combat winter. Its name is the water bear. A microscopic organism with 8 short legs, living in a thin film of water. When water is present, it crawls, feeds, and reproduces like a normal animal. But when the environment begins to freeze or dry, it stops its activity. It begins to remove water from its body. The legs retract slowly inward. The body shortens and the creature curls into a structure called a tun. Inside the body, metabolic activity drops to an extremely low, nearly stagnant level. Protective proteins help stabilize cell membranes and biological structures as water disappears. It is not truly immortal, nor can it survive every condition forever. But in cryptobiosis, the boundary between living and non-living becomes unrecognizable. No heartbeat, no breathing, no movement, no normal activity to define a life. Winter may continue to cover the moss. Water may freeze completely solid. And this tiny creature remains still. It does not fight, it simply waits. When liquid water returns, the body begins to absorb moisture and expand. Cellular activity is gradually restored. The creature once thought lost crawls again. Reindeer keep heat. Squirrely lower temperature. Musk oxen rely on thick insulation. Arctic foxes reduce heat loss. Polar bears rely on fat. Penguins huddle together. Snow leopards save energy. Antarctic fish prevent ice growth. Wood frogs freeze. But the water bear does something extreme. It nearly pauses life itself. It waits for the world to become livable once more for its species. The water bear crawls through a moss fiber in the newly formed water. The camera slowly leaves the microscopic world, pulling out from a single droplet. The droplet sits on green moss, revealing the vast forest and mountains. Life doesn't just endure winter. It changes the very definition of being alive. From reindeer crossing the frozen tundra to a creature smaller than a grain of sand. Every species has found its own way to survive. Some preserve heat with thick fur. Some slow their metabolism until life becomes almost impossible to detect or see clearly. Some depend on the entire group to resist the wind and the freezing Antarctic cold. Cold does not produce one single strategy. It produces hundreds of different survival answers. In the coldest places on the planet, the answer may be hidden inside thick fur. Or it may exist within a single protective molecule deep within the animal's cells. These animals have transformed places that appear impossible to inhabit into their permanent homes. Because on this planet, life rarely disappears. It simply changes the way it survives.